Alright, in this video we're going to wrap up section 9.2 with looking at example number 2. This is just a good all-around practice. For this video we're going to be looking at descriptions of chemical reactions, and from that we're going to have to write the chemical equation, make sure we predict the states of matter correctly for every single chemical that's involved, and then finally we're going to balance it. So it's just, like I said, a good all-around practice for what we've learned so far. So let's take a look at the first one. It says solid sodium reacts with water to produce hydrogen gas and an aqueous solution of sodium hydroxide. So let's just take it piece by piece, making sure that when we're writing out the chemical equation, every chemical formula needs to be written correctly. All right. So taking a look at what we've got going on here, we've got solid sodium. Okay, so sodium is Na, and it even tells us that it's solid. Now, if it didn't tell us it was solid, we should still know that because sodium is a metal, and all metals are solid unless it's mercury, right? So that's solid sodium is reacting with water. Okay, so hopefully there's no confusion as to what water is. Okay, however, we do need to make sure we put the state of matter for water, which is liquid. Okay, and those two things are going to react to produce. The first product is hydrogen gas. Now, hydrogen is a diatomic. Okay, so we need to make sure we remember that it's H2 and not just H. State of matter, it tells us it's hydrogen gas, but even if it did not tell us that, we should know that hydrogen is a gas. And then the second reactant, or second product, excuse me, is aqueous solution of sodium hydroxide. So this is a compound. Okay, so we've got sodium hydroxide, right? And so sodium is Na, hydroxide is OH. Okay, and so make sure when you're writing a chemical compound, you need to make sure that the charges cancel out to be 0. Sodium is +1, hydroxide's -1, so it's good to just have one of each. And it tells us it is aqueous. So after that, I'm going to put an AQ, okay, to indicate that it's aqueous. The last thing we need to do is we need to balance. So we've got one sodium. We've got 2 hydrogens, 2 plus 1, so 3 hydrogens total on the product side, and then 1 oxygen and 1 oxygen. So right now, the hydrogens are what's not to balance, and you notice that there are an odd number of hydrogens on the product side. Okay, so I want to get rid of that. So the way I can make the hydrogens even is if I put a number 2 here. Okay, so by putting a 2 there, now I have 2 hydrogens here plus 2 hydrogens over here, so that's 4 total. So to make 4 hydrogens on this side, I'm going to put a 2 in front of the water. Okay, and so now my hydrogens are balanced. Now my oxygens are also balanced based on what I did. I have 2 oxygens on the reactant side, and I have 2 oxygens on the product side, so that's all good. The last element I have to balance is the sodium. So I've got 2 on this side, 1 on this side, and so I'm going to go ahead and put a 2 right there. All right, let's look at another example. Let's look at example number 2. Very similar to what we did before. We just need to write out every chemical formula correctly, make sure we have the states of matter correct, and then finally balance. So to get started, we have solid iron reacts with oxygen gas to produce solid iron 3 oxide. So let's just take it piece by piece, start writing it out. First of all, we have solid iron. Okay, iron is just Fe. Okay, it tells us that it's solid, but we should know that iron would be solid because iron's a metal. And that's reacting with oxygen. Remember, oxygen is a diatomic, so it needs to be O2. Oxygen is in gas, and it's going to react to produce iron 3 oxide. This Roman numeral 3 means. That Roman numeral 3 means that iron has a charge of +3. That doesn't mean there's 3 ions, right? So iron is a +3. Oxide comes from oxygen, which is -2. So if you think about iron and oxygen reacting together with those charges, the formula for our product is Fe2O3. And it tells us that it is solid, so I'm going to put a solid right after that. Finally, I need to balance. I notice with my oxygens, I have 2 on the reactant side and 3 on the product side, so there's that 2-3 ratio we were talking about. So to get rid of that and make it a least common multiple of 6, I'm going to put a 3 in front of this oxygen, and I'm going to put a 2 in front of that. And so therefore, my oxygens now are balanced. And then if I look at my irons are 4 on the product side, so I need to put a 4 on the reactant side. Last one, let's go ahead and take a look at example number 3. Solid potassium carbonate decomposes. Okay, so there's only one reactant here, and it's potassium carbonate. Potassium is K, carbonate is CO3. Now, make sure that you're writing out these formulas carefully, right? So potassium is +1, carbonate's -2. So to make sure that this is written correctly, it needs to be K2CO3, right? That's the correct way to write potassium carbonate. Okay, it is solid, so I need to put a solid right afterwards. And that's going to decompose into two things. It says it decomposes on heating to give solid potassium oxide and then carbon dioxide gas. So we have two products here. First one is solid potassium oxide. Okay, so potassium is K, oxide is O. Potassium is +1, oxygen's -2. So if we think about how to write this formula here, potassium oxide, it's going to be K2O. And that is solid. Okay, and then finally plus, your second product is carbon dioxide, and it tells me that it's gas. So now all we have to do is balance. Okay, I've got 2 potassiums on the reactant side, 2 potassiums on the product side, 1 carbon, 3 oxygens, and if I look, I have 1 oxygen here, 2 oxygens there. It's already balanced, right? Just real quickly, if I had written, and this is a common mistake, if I had written, whoops, let me put the carbon back. If I had written potassium carbonate incorrectly, which a lot of students do, they just write potassium carbonate like this and they don't write it correctly. This would have been impossible to balance, right? Because you would have seen, oh, potassium over here, 2 there, so I got to put a 2 in front of here. And they would have, you would have just gone back and forth, and it never would have balanced. And so that's why it's really, really, really important. Let me go ahead and write this correctly again. That's why it's really important. Make sure you're writing your formulas correct, so that way you get the correct balanced chemical equation. That wraps it up for section 9.2. We'll go ahead and see it in section 9.3.